What if I told you that the faintest glimmer of light captured by a telescope floating 1 million miles from Earth has just rewritten our understanding of the universe's very beginning? That glimmer belongs to a galaxy called MUMS 14, a system so distant, so ancient, that its light set out on its journey when the universe was less than 300 million years old. To put that in perspective, if the age of the universe were compressed into a single 24-hour day, MUMS 14 was already shining before the clock struck 1 a.m. Now picture what the cosmos looked like at that time. The Big Bang had passed in a furious blaze, leaving behind a universe filled mostly with darkness, scattered clouds of hydrogen and helium drifting in an endless sea. The first stars were just beginning to flicker awake, fragile and short-lived, blazing through the gloom. Galaxies as we know them were only whispers of what they would one day become. Tiny, chaotic, trying desperately to pull themselves together. And then, out of this fragile wilderness, Webb's golden mirrors revealed a surprise. A compact galaxy, shining far more brightly than it had any right to. A galaxy not tentative or half-formed, but burning with the furious energy of youth. That galaxy is MOM-Z14, the earliest confirmed galaxy we have ever seen. Its discovery is like stumbling across a roaring campfire in the middle of a cold and barren desert night. It shouldn't be there, it shouldn't be burning this strongly, and yet it is. And its very existence forces us to ask, how could something so luminous, so well-formed exist so soon after the birth of the cosmos? But before we jump in, I have a quick favour to ask. We're just getting started, and your support really helps us grow. So if you're enjoying this, please hit the like button and subscribe. Thanks so much, and now let's dive into today's mystery. If MUMS 14 is a beacon from the dawn of time, then the only reason we can see it at all is because of one machine, the James Webb Space Telescope. Normal telescopes, even the mighty Hubble, are blind to the faintest whispers of the early universe. The problem isn't the distance alone, it's the fact that the universe itself has been stretching ever since the Big Bang. As space expands, the light travelling across it is stretched too, shifting it into longer and longer wavelengths. What once began as ultraviolet or visible light from those newborn stars is now stretched into the infrared, a range of light invisible to human eyes. This means that if you pointed a regular telescope at MOM-Z14, you wouldn't see anything at all. It would be as if the galaxy were never there. But Webb is different. With its enormous golden mirror spanning 6.5 meters, Webb is built precisely to catch this stretched out light. Its instruments like NIRCAM and NIRSPEC are designed to pick apart faint infrared signals, cosmic fingerprints that have traveled more than 13.5 billion years through expanding space. Think of it this way. Imagine shouting across a canyon. Your voice is clear at first, but the farther it travels, the more it echoes, distorts, and stretches into a faint murmur. By the time it reaches the other side, only a highly tuned ear could recognize it. Webb is that ear, tuned not just to hear the faintest murmur, but to decode what it means. When Webb sensors finally registered MOM-Z14, what they captured was not just an image, it was a time capsule. The light striking its mirrors left this galaxy when Earth didn't even exist, when the Milky Way itself was still a dream waiting to be assembled. And yet, despite travelling across 13.5 billion years of cosmic expansion, the signal was still there. Still strong enough to tell us about the galaxy's size, its brightness, even the types of elements burning within its stars. Webb didn't just spot MOMS-14, it reached across time, pulled back a curtain of 13 billion years, and showed us a piece of the universe's lost childhood. And that is where the mystery deepens. Because what Webb revealed about the anatomy of this galaxy, its size, its power, its furious energy, doesn't line up with what our theories say should exist at such an early moment in time. When Webb's golden mirrors first captured the faint glow of MOM Z14, astronomers expected to see a ghostly smear of light, something fragile, scattered, still trying to assemble into a galaxy, but that's not what they found. MOMZ14 may be small, but it is anything but fragile. At just 240 light-years across, it is hundreds of times more compact than the Milky Way. To give you perspective, if our galaxy was stretched across the United States, MOMZ14 would fit neatly inside a single city block. Yet within that block is a storm of stars, packed so tightly together that the galaxy blazes like a beacon against the cosmic dark. Now here's the paradox. Small galaxies usually shine faintly. They're dim clusters of gas and dust, struggling to ignite enough stars to be noticed across the cosmos. MOMZ14, however, burns brighter than anyone expected. Its ultraviolet light is so intense that even across 13.5 billion years of travel, Webb could pick it out. And what's even more remarkable is what's missing. When galaxies glow this strongly, astronomers often assume a black hole is hiding at the center, devouring matter and blasting radiation outward. But Webb's data shows no such evidence, no active galactic nucleus, no ravenous monster at its core. MOMZ14's brilliance comes from stars alone. Picture it like walking into a room and seeing a candle flame, then realizing it isn't a candle at all, but a bonfire burning at full force. That's what MOMZ14 represents. A stellar inferno compressed into a space so small it defies our expectations, and its light is telling us something else. The stars within MOMZ14 are astonishingly young and pristine. Their colours suggest almost no dust, which means these stars are likely among the earliest generations to form in the universe. We are, in effect, watching the universe learn how to make galaxies. So here is the riddle. How can something so tiny, so early, shine with the power of a galaxy much older and larger than itself? The answer may lie in what happens next, because MOMZ14 isn't just shining, it's exploding with activity. It is in the middle of a stellar baby boom, a period of growth so intense it could reshape everything we thought we knew about how quickly galaxies can form. Webb's instruments revealed that this tiny galaxy is in the midst of a furious starburst, forming stars at a pace nearly 10 times faster than it was just a few million years earlier. To put that in perspective, if the Milky Way were a slow-burning fireplace, MOMZ14 would be a fireworks display going off all at once. But it isn't only the speed that's shocking, it's the composition. By analysing the faint fingerprints of light, astronomers found unusual chemical signatures inside MOMZ14. Elevated nitrogen relative to carbon. Why does that matter? Because it mirrors something strange we see closer to home, the ancient globular clusters orbiting our own Milky Way. These clusters, made up of stars nearly as old as the universe itself, carry the same nitrogen-rich signature. It's as if MOMZ14 is showing us the recipe book for building the very first stellar communities. Were these stars enormous, short-lived giants that lived fast and died young? Did their explosive deaths enrich the galaxy with elements that seeded new generations? Every piece of evidence points to one conclusion. MOMZ14 is not just a galaxy. It is a stellar factory, racing against time to fill the universe with light. And yet, this raises a troubling question. How can a galaxy so early, so small and so new already look so busy, so alive, and so enriched? The discovery of MOMZ14 doesn't just give us a new record holder for distance, it gives us a paradox. Because galaxies like this shouldn't exist so soon after the Big Bang. The discovery of MOMZ14 leaves us with a problem. According to our best models, galaxies in the first few 100 million years after the Big Bang should be fragile, dim, and struggling to survive. They should be flickers of light, not blazing beacons. And yet here it is, tiny, compact and already burning with the brilliance of a fully fledged galaxy, it's as if we walked into a forest where every tree is only a few inches tall, small shoots just beginning to break the soil. And then, in the middle, we find a massive oak, towering and fully grown. That oak is MOM-Z14, and its presence throws our timeline into chaos. How could a galaxy grow this quickly, this early? We know that galaxies typically form through slow accumulation. Clouds of gas collapse, stars are born, clusters merge, and over billions of years a galaxy takes shape. But MOM-14 seems to have skipped those careful steps. Instead of gradual growth, it appears to have leapt ahead, an overachiever in a universe that had barely begun. And this is where the paradox deepens. If MOM-14 exists, it may not be alone. If Webb can find one galaxy blazing so early, then surely there are others waiting to be uncovered. This forces astronomers to ask a question that touches the very heart of cosmology. Have we misunderstood how galaxies form in the first place? Because if galaxies like MOM-14 really did bloom so soon after the Big Bang, then the rules of cosmic evolution may be far stranger than we imagined. And to answer that, we must turn to the theories, bold ideas that challenge the very foundations of how the universe built its first structures. So, how can we explain MOM-Z14? Astronomers have begun to weigh several bold ideas. Each one challenges the way we thought galaxies were born. One possibility is hyper-efficient star formation. In this scenario, the first pockets of gas in the young universe were so dense, so pristine, that they could collapse into stars far more quickly than we see today. Entire clusters could have sprung up almost at once, flooding MOM-14 with youthful, blazing light. Another idea points to exotic chemical enrichment. If the very first generation of stars, enormous short-lived giants, exploded as supernovae, they could have seeded their host galaxies with unusual patterns of elements. MOM-14's nitrogen-rich signature may be the fingerprint of those early titans, a clue that we are seeing the ashes of the very first stellar deaths. And then there is the possibility of an illusion of brightness. In the early universe, galaxies may have contained little or no dust. Without dust to block or scatter the ultraviolet radiation, more light escapes directly into space, making these galaxies appear brighter than they actually are. Perhaps MOM-14 isn't impossibly massive, it's simply unusually transparent. Each theory pushes us to rethink what's possible. Perhaps galaxies could grow with staggering efficiency. Perhaps the first stars shaped their surroundings in ways we never predicted. Perhaps the rules of brightness themselves were different at the dawn of time. The truth may even be a combination of all these ideas. But one thing is clear. MOM-Z14 is no ordinary galaxy. It is a riddle written in starlight, daring us to solve it. And its very existence means our picture of the early universe may be incomplete. Before the James Webb Space Telescope, the record for the most distant confirmed galaxy belonged to GN-Z11, at a redshift of just over 10. For years, it stood as the outer limit of what we could see, but MOM-14 has shattered that boundary, pushing us deeper into the universe's past than ever before. With a redshift of 14.44, it shows us light from only 280 million years after the Big Bang. It is not just a new record holder, it is proof that galaxies were already thriving far earlier than our models allowed. This discovery forces us to rethink the timeline of the cosmic dawn, the epoch when the very first stars and galaxies lit up the darkness. We once imagined this process unfolding slowly, gradually, across hundreds of millions of years. Now we see evidence that it may have ignited in a sudden blaze. If MOM-Z14 existed, then galaxies like it must have been more common than we believed. Whole populations of early galaxies may be waiting just beyond our current limits, hidden until Webb's infrared eyes reveal them. And if the universe could build these structures so early, then our understanding of cosmic history is incomplete. The rules we thought were fixed about how fast stars can form, how quickly galaxies can grow, and how soon the first structures could take shape may all need to be rewritten. Mom-C14 is not an outlier. It is a messenger, a reminder that the universe has surprises waiting for us at every turn, and that the first chapters of cosmic history are far more complex, far more dynamic than we ever imagined. And that was our episode for today. Thanks so much for watching. If you enjoyed our video, don't forget to hit that like button and subscribe so you don't miss what's coming next. We've got plenty more mysteries to uncover together. See you in the next one.